Hi guys, my name is Shaurya and I'm from DevClub IIT Delhi, and I'm here with Pathways who have curated for us this really nice course on LLMs. And we'll be starting off today with the basics of LLMs. And yeah, pretty excited to present this course to you guys. Welcome to the fascinating universe of large language models or LLMs, as they're more commonly known. And this is the first module. We'll be having multiple modules in this bootcamp. And as we delve into this innovative segment, of our AI, understanding foundational elements are crucial. So this is what are these models? How do they work? What goes on in the back, right? So we all know ChatGPT in the front. We all have, opened and played around with, ChatGPT, maybe some of us, Bard, Claude, all of these different models. But like, over here we'll be understanding what actually happens at the back, what is the significance and use case of such LLMs, and is it just text? Maybe is it video? Maybe is it photos? Or is it what kind of stuff can it generate? What is generative AI in itself? Why is it called generative AI and not just AI? All of that sort of stuff we'll be learning in this course. So yeah, let's start. So what is generative AI? Um, well, so does anyone really understand why we call this generative AI? Why is the word generative used? Um, Anyone, you can just unmute and speak.
It's because it generates self-content. It generates the content by itself.
Okay, good. So it generates content by itself. Exactly. So one one is when we have two types of tasks. We have abstractive tasks and extractive tasks. So extractive tasks are those tasks where you're given some content initially, and then you use that content to create, you use certain parts of that content and then create new content. The other one is abstractive or generative, where what you do is that you're given content as a prompt or some basic information, and then all the content being generated is totally new content, not based on the old content that already is provided to the model. So the LLMs of today are generative in nature, because with a small little prompt, like a small little hi, hello, bye, etc., they'll actually generate a response to you which is not part of what the information that you have provided to them is, right? So now we'll move on to what is a large language model itself. So, we have to first answer this, you all have probably heard this buzzword, right? LLM, large language model. So what is it and why is it important and how does it actually generate text is what we're going to understand over here. So let me quickly play this video for you guys. I hope the video's sound is audible.
We've all used some kind of generative AI, whether it be a chatbot to have a friendly discussion with an AI, or whether using one of those websites where you can type in a description of an image and it will generate a brand new piece of artwork just for you. Behind the scenes of all of those applications are generative AI models. And when it comes to text, it's a large language model. And this has got everybody excited, not just the general public, but data scientists too, because they're capable of doing way more things than maybe we even anticipated. In the past, if we wanted to do things like sentiment analysis or the summarization of text, we'd have to train a specific model to do just that task. But now with large language models, we're finding that they're capable of doing a lot of these natural language tasks for us in one model. So whether it be writing a letter or doing summarization or doing sentiment analysis, large language models can do them all. Now, in this series of videos, we're going to step through some of the basics of large language models, such as how they work. So join me in the next video where we'll start to talk about the terminology of large language models and just a little peek into how they work.
Okay, so he used a few fancy words over here. One of those words was sentiment analysis. Does anyone know what sentiment analysis is?
To know the mood of the public by their comments.
Okay, so if I write some, okay, can you give me an example of a positive statement, for example? something like well done or excellent. These are positive, statements. Similarly, you have some negative statements like this was terrible, or this didn't make sense, right? So to analyze what the sentiment of this text is or the mood of this text is what sentiment analysis is. Similarly, he talked about summarization. Now, summarization could be that you're given a long, letter, and now you're summarizing this by just extractively summarizing this, which is that you just extract small little paragraphs or small little phrases and then you put it together to get a summary. The other is generative in nature, which is what we can now do with LLMs, which is that you can actually paraphrase or use certain small points to paraphrase and grammatically patch together a very comprehensive and understandable summary. Another thing that he used over here was writing a letter. Now, when you write a letter, right, you can only do this with generative AI, where what's happening over here is that you specify your problem statement, to specify this is the reason I want the letter to be written, and then it generates for you this letter, right? So all of these things come into generative AI's domain. And while, before what we would have to do is we would have to train small models, small machine learning models to do, each of these things. For example, sentiment analysis used to happen with these small machine learning models. Now we can do all 3 or 4 of these tasks with one singular model, which is what we call an LLM, right? Okay, sure. So, yeah. So let's understand large language models now. So imagine a language model as a brilliant system that can predict the next word in a sentence. So it's very similar to a friend who is good at guessing the end of your sentences. But this friend has read almost every book available and remembers them all. It uses this vast knowledge to make educated guesses about the next word on based on an already used words basis. So, okay, does anyone know what would happen if I ask ChatGPT to write a 200 word summary of of a paragraph, or if I ask ChatGPT to tell me how many words are going to be there in its next message? So if I ask ChatGPT, tell me how many words are going to be there in your next message, or write me a 200 word summary. What do you think is going to happen? Will it be able to do something like this? Come on, guys, just unmute, speak. It could be right, could be wrong, doesn't matter.
No, it would require the original content on which it would work and generate a summary.
No, no, I provided the original content, but I specify a word limit. I say
Okay.
the summary should only be 200 words long. Do you think it will be able
Yeah.
to generate 200 word long summary?
Yes.
Okay,
Yes.
and what if I ask it?
I don't think
Sorry.
there will be a problem to write a 200 word essay. I mean, I think it should be able to do it. I never tried it.
So
Yeah, it will be able to do it.
will it be able to do exactly 200 words? Okay, what about if I ask it, can you tell me how many words are going to be there in this sentence? Will it be able to tell you how many words are there in its response?
Yeah, this I have tried to. I
Okay,
asked it how many words are there in your response, and it just told me the correct one.
it told you the correct one.
Yeah.
Okay, let's try it. Okay, for like a short. So as you
That's
can see,
actually seven.
yeah, exactly. So you see, it can't. It makes mistakes while doing something like this. Or if I ask it, write me a 200 word essay on the topic of LLMs. So let's check. So you see these inaccuracies. Can someone explain to me why these inaccuracies exist?
Can you also, write on ChatGPT then count the words of the essay you wrote?
I mean, that is not the point exactly, but okay. Write a 200 word essay on the topic of LLMs. You count the number of words you wrote in the previous lesson. and you can clearly see that it's not able to do something like this. But that's not really the point I was making. Anyways, so can someone explain why these inconsistencies exist? Especially, tell me the number of words in your next response, something like that.
Is it because of tokens? The number of tokens can actually be larger than the actual
No, it's
words.
not that. No. Okay, fine. So the reason is that the way LLMs work is they're all probabilistic prediction models, which means that what they do is they only know the next word that is coming out. For example, when it outputted, you remember it outputted there are 8 words in this response. So when it put there are, and then the next word had to be generated, it generated 8 based on 8 being the most probabilistically a true number that should have been generated after putting the words there are. Okay. And it's not exactly 8, it's actually tokens that it's predicting. But the point being that 8 is the most probabilistically true token that was generated. And after that, the next 3 words were generated based on these 3 words, right? Based on what is probabilistically most likely, right? But it didn't actually reason through this. There was no like logic behind something like this. The point I'm trying to make over here is that it can only predict the next word and output the next word based on the previous word in the particular sentence, or previous words in the particular sentence. So it doesn't know how the answer is going to end before the answer actually ends. Yeah, exactly. So when it's selecting 8, it didn't already know what the future words are going to be. It just knew that the next word is most probabilistically going to be 8. So this is a very important thing that you're supposed to understand about these stochastic parrots, which is the fact that they are just probabilistically, true models where they will make educated guesses about the next word, but they don't specifically know the remaining words, or they don't specifically have an innate ability of reasoning, quote unquote, in this context, right? So, for example, simple words like bird flies in the sky. The language model can quickly tell that the bird flies in the sky is a logical sequence, whereas sky the bird flies in doesn't make. So, what this helps the language model to do, the LLM to do, is it helps it to logically predict a sentence of words that like a sequence of words that make a valid grammatical sentence. Because if it's trained on all of the data that you can, it's like quote unquote trained on all the data that's in existence, and all of these books and language mod, like all these reports and books and things that it's trained on would always have grammatically correct sentences written in them because they were human written, right? So the point being that probabilistically predicting the next word would ensure that your next word will probably only create a grammatical sequence that's like logically correct and semantically correct and grammatically correct. So you won't end up with badly written sentences. You will most likely always end up with good, well-written sentences. So this solves for grammatical issues, but it doesn't solve for actual reasoning issues, like because there is some magic or some magical reasoning module that's running. It is simply a probabilistic module, right? So these modules aren't just guessing, they're about understanding flow and rules of language. So, and then this is where the beauty comes, which is that while while this is at its essence, it's guessing words, but because it is trained on such a large data set, we have realized that they also, in some abstract form, understand the flow and rules of the language, almost as if they've absorbed some of the essence of how we communicate. So we don't say they actually have absorbed some of the essence. It's almost as if they have absorbed. So there is a nuanced difference over here. So modern LLMs, especially those built on transformer architecture, which we'll cover later, leverage deep learning techniques to analyze and generate text. These advanced neural networks are adept at understanding context and generating coherent, contextually appropriate text. Think of these models as having an integrated web of neurons and mimic a human brain, allowing them to grasp subtleties of language and produce responses that feel surprisingly human-like. So again, you know why we're using words like feel surprisingly human-like? Almost like they're able to grasp the subtleties. Because in reality, they aren't. There's no magic going on at the back. It's just probability that is at work, and math that's work with a huge amount of neurons, just like a human brain would work, right? The way your human brain works is that there are a huge number of neurons, and each neuron communicates with the other through receptors, chemical receptors. Similarly, over here, each neuron communicates with the other with what we call mathematical weights. And the way it's trained and the way it generates content and the way it generates the next word, all of these things are very similar to how our human brain actually tries to think and reason. So it kind of mimics this thinking and reasoning while, not actually, like physically doing it. It's just mathematics, right? So a brief history of LLMs, of course. So journey of language model began with Claude Shannon's curiosity about communication and information theory in 1948. This led to a lot of practical applications in speech recognition and machine translation around the 1980s. Initially, these tools were simple, using basic counting methods to guess the next word in a sentence. So basic counting methods at that time were like simple frequency, like what is the highest frequency, right? Or something like, key, okay, based on the last word, what is the next word, right? And then at the advent of neural networks with this paper. So when you read Benjo et al., this means that there was this paper that was released in 2003. This marked a significant leap forward. Think of neural networks as a way for computers to start thinking about more words and sentences they encounter. Somewhat like how we understand conversations by considering their context. So like when I am having this conversation with you guys right now, you guys know the context around each and every sentence or each and every word I said because of the sentence that word is in or the paragraph that word is in. Similarly, using this neural network architecture, you could basically consider the context of the entire sentence to predict the next word or the entire paragraph so far to predict the next word instead of just the previous word or just the previous two words or just the previous three words. This allowed models to consider longer text sequences and understand more complex patterns. So obviously, as you consider more and more context, that you consider more and more of the history of what is being output right now to output the next word or the next word in the sentence, the next token in the sentence, you will be able to identify much more complex patterns because the data set being entered, which is all the previous words that have been generated so far, becomes higher and higher because the data set becomes larger and larger. You're able to predict better and better, and you're able to predict using much more complex patterns that allow for better, quote unquote, better reasoning, right? So then came the recurrent neural networks, RNNs, and long-term LSTM networks. So we'll cover, like, I hope a lot of these things in the rest of the course, but these allowed computers to remember what they read a few seconds ago, helping them use past information to make better prediction about what comes next. This is a significant step forward because previously models could only look at a few words at a time without remembering the early parts of the sentence. So this is exactly what I'm saying, that basically what RNNs and LSTMs did, they were like deep learning techniques in ML, and these ML techniques, right? That allow, in like some sense, the model to be able to remember more and more context of what has been generated previously as compared to just a few words from before. So then 2017 saw a very famous paper. So as you can very kind of as you can probably predict, right? The more and more context that you must store in order to generate the next word, the more computationally expensive this task could become, right? So basically, if I have to get the model to use, in some mathematical way, the last uh, 15 paragraphs that have been generated to build context for the next word that is being generated, this would be quite computationally expensive. And a lot of the leading architecture that we had at that time, a lot of the leading GPUs and compute power that we had at that time, through classic machine learning methods, were not able to provide fast enough results that was commercially viable to use such a technique. But then what happened was in 2017, a paper was published called Attention is All You Need. This is by Baswani et al. And it led to the development of BERT and GPT. So the point is that this architecture, this transformer architecture that used this attention mechanism, which was basically that it used certain, it paid more and more attention to certain hotspots, quote unquote, in the last, previous 15 paragraphs, let's say, to create good context for the next word that is to be generated in a very efficient way. Okay, ensured that you could actually, in a very proper and reasonable and viable way, use a lot of the previous context in order to generate the next word. So this kind of created this architecture and this model, and we'll cover what transformer architecture was in the coming sections in order to, generate the next word. So, and it led to the development of BERT and GPT. So, and the transformer architecture is the backbone of the most popular LLM so far. So, be it ChatGPT, Bard, Claude, Mistral, Llama, transformers improved upon RNNs and LSTMs by better handling sequences of words. So this was a design thinking that occurred over here through this attention architecture that allowed for handling of large sequence of words in order to generate context in a very efficient manner to generate the next word. So Okay, so yeah, lots of big words used over here, of course, and you guys can definitely go through the course material, read the paper, read the original paper, Google, take it as homework almost. Google what BERT is, Google what GPT is. But yeah, something I think you guys would probably know already was so out of these models listed here, Chat GPT, Bard, Claude, Mistral, 7B, or Llama 2. Can you guys tell me which of these are closed source models, which of these are open source models, and what companies are behind each of these models? So can someone unmute and tell us all about
ChatGPT is
this?
OpenAI, open source,
Okay. No. So
and
ChatGPT is OpenAI, but OpenAI is not an open source company. In fact, very funnily, Elon Musk is currently suing OpenAI for a few million, hundreds of millions of dollars, or maybe even $1 billion. That they call themselves OpenAI, and their mission was to be open, but in reality, they are actually a closed source AI company which has proprietary AI technology that they're not ready to share with anyone. Bard, anyone knows about Bard? Sorry.
Its name is
It's
Gemini.
by Google.
Exactly. Bard is by Google. So Google is again a closed source, large company, and Bard is also a closed source model. It's proprietary to Google. Claude, I'll make it easier. Claude is by Anthropic. So Anthropic is a new company that within a year and a half has actually created some of the leading industry standard models right now that are used for safer generation of content. Okay. And their mission statement is that they need to create content through generative AI that is safe and humanistically safe, and everything is like secure and safe and nice, and it's usually a helpful harmless model. It can't create like insults, it won't do bad things in general, right? And for that they have pioneered a technique called constitutional AI, and we'll probably get into this at some point, right? So Mistral 7B is by a French company, and it is a completely open source model, which means that you have the weights of the model and you have the entire model itself. Does anyone know what 7B is? 7B, does anyone know what 7B means? Okay, so 7B means that the Mistral model has 7 billion parameters or 7 billion weights. So, you know what I was talking about where I said that there are a lot of neurons connected by weights, just like the neurons in our brains are connected by chemical receptors. Well, similarly, in Mistral's model, there are 7 billion such weights that connect these neurons together in order to help the model generate. So, similarly, like different models have different number of such weights at the back. So Llama 2 is by Facebook or Meta, right? Anyways, Transformers improved on upon RNMs and LSTMs by better handling sequence of words. Instead of reading a text one word after another, Transformers can pay attention to multiple words at once, which helps them understand the context more effectively. And while so far we've covered, so okay, and this history doesn't cover all significant events, and it wouldn't be correct to call this an oversimplification. But the essence of this context was to make you imagine how so many things went right for us to read this coursework today. The point is, does value of one weight correspond to one neuron? Okay, very interesting question. I think we'll take such questions at the end of the session because these require a little bit more intricacy, and I think Mudit would be a much better person to answer such questions. But we'll take these at the end of the session for sure. And the exciting part, we're still just scratching the surface. There's so much more to explore and discover in this field. Perhaps you might even join in and contribute to the next big discovery. So let's go to the advantages and applications of LLMs. So as future engineers and innovators, it's crucial for you to not only understand large language models, but also to envision and develop solutions that tackle significant social and business challenges using this technology. However, the potential areas of LLMs are rooted in several key advantages they offer. Let's briefly explore these foundational benefits. Okay. So before I actually go through it, okay, I'm gonna hide that. Can anyone like maybe help us understand what LLMs are good for? So what is so special about LLMs? Why are we having this session today? Why are we so obsessed with them? What are they so good for? Why are they so great?
sir, it is a very crucial use for these days. Like all the students are using it. Everything you need to write an essay, you need to write a message, you need to leave someone a special note or something. You use ChatGPT or any other source to give you that piece of thing. So yeah, it is a really very commonly used. Right?
okay, why do we call it? That's good. That's true. That's absolutely right. You can do a lot of things at once, right? Um, can you also tell me why is it called large language model? What does large mean? I covered it. Like I gave you guys a hint when I said 7B. What does large mean in large language model?
It
It is
can be
trained
that it
on
is.
a very large data set.
That it's trained on, right? So when you say 7 billion weights, right, we are basically talking about a very large model. Not only is it trained on very large data, it is also in itself a very large model where there are 7 billion parameters that are ensuring that that model actually operates. So the computation power required to actually operate these models is very, very high right now. So yeah, advantage of LLMs over traditional neural networks. One is the scale of data. The training on extensive data sets enhances LLM's context understanding, leading to more advanced outputs or much more nuanced outputs. So the rise of deep learning and significant hardware advantages, of course, GPUs is what we're talking about, has led to allowing such a large scale of data to be the training data set at the back. The second is transfer learning. So similar to learning different sports after knowing a few, LLMs apply knowledge across tasks without starting from scratch. So the point is that basically, if you tell it a little bit about some domain and some particular things in that domain, it will actually transfer and try and apply that same knowledge to other parts of that domain without you actually telling it that much about the other parts of the domain. So that's called transfer learning. Contextual understanding, we covered this. Using the attention is all you need. The attention and transformer architecture, it can perceive larger text context, not just isolated words, which allow it to create much more nuanced outputs. And multitasking ability. So capable of handling diverse NLP tasks, unlike specialized traditional networks. So I mean, natural language processing tasks, it can do lots of different things. It can do attention. It can do it can grammatically correct itself on the fly. We'll go through a couple of these later. And when they say NLP tasks, so they're talking about more like creating letters. It can create a letter. It can check for grammatical inaccuracies in a this thing. And paraphrase something. It summarize something. It can do sentiment analysis. All of that sort of stuff. So even if you're not part of a dedicated LLM research team, knowing the common domains where LLMs are applied is crucial. It gives insight into investors' priorities and the areas where LLM can drive substantial value. One widespread use case is for efficient knowledge extraction for a vast corpus of data. But yeah, we can go get a bit more specific. So customer service is a huge use case right now. This is chatbots. Healthcare, drug discovery and diagnostics is a huge use case. Creative writing or content creation, this generative nature of LLM is a huge use case. Financial sector in terms of fraud detection, summarization of financial meetings, summarization of documents, document generation, taking down minutes, all of these are use cases, right? And then you finally go on to creating novel solutions with real-time LLM applications. So building a real-time system fundamentally revolves around processing, streaming data, handling new information as it arrives, and incrementally indexing its efficiency for LLM. So basically, the point is that with LLMs, you can create more real-time applications. You don't need to pre-train something, right? Because of the fact that LLMs themselves are completely pre-trained models, you can actually have some text coming in real time, in like right now, and you can have outputs being generated right now without actually having to wait for those outputs to start getting generated. And the evolving scope obviously contains multimodality. So anyone knows what multimodality is? Can someone define multimodality? Okay, so multimodality is a capability of an LLM to not only generate text, but also generate images, to generate videos, to generate maybe a PPT, or any sort of output that is not text. Also, is also a generatable output because all you do is instead of training the LLM on a lot of books and a lot of text data at the back, you train it on a lot of video data at the back, or you train it on a lot of audio data at the back. If you want to generate audio, if or you or you train it on a lot of picture data at the back, you're going to generate pictures, right? So the point being that this multimodality or this capability of LLMs, large language modules, to output different types of output formats like videos, pictures, etc., is what we call the multimodality. So this is an evolving field of research right now. OpenAI has come up with Sora, for example. Sora is this cutting edge model that basically generates videos, full-fledged actual movie grade videos from simple prompts. So I can show you something like this. So uh Sora demo OpenAI, right? So this is a very, very cool, this thing where all of these videos, for example, you see this video over here, this is generated from Sora. This is the prompt that they put in. A litter of golden retriever puppies playing in the snow, their heads popping out of the snow. And right with this, you have got this video that's generated. So you can see how incredibly powerful this is, right? And this is all part of the multimodal aspects of LLMs, where, this entire video, every last bit of it, each and every pixel that you see on the screen, each and every frame that you see in this video, all generated using Sora, OpenAI Sora, right? So this is a huge evolving scope of research right now, and expanding domains are reducing. So, okay, does anyone know what hallucination is? Okay, so hallucination is basically this property of the LLM by which, because it is trained on so much data, so much data, sometimes what it does is to complete an answer or to just probabilistically answer, put out the next word, it actually ends up hallucinating or going down a stream of words or outputting a sequence of words that are not actually true or are just generated or just randomly, outputted. For example, if you ask ChatGPT, hello, let's do this exercise, okay? You know, uh, it's not exactly generation of data that LLM doesn't know. It could also be data that the LLM has been trained on in some way, but because there are so many conflicting training sets that are coming into play, because it's so large and there is some weight somewhere in that entire 7 billion parameters, for example, that's ending up putting the LLM down the wrong path of generation, where the next word being generated is wrong, it ends up hallucinating. For example, what is the like forget current data. For example, what is the uh, number of people in India? Okay, so or for example, I ask it uh, yeah, due to fuzzification. So that's a good one. So what is fuzzification? This is that if I have a set number of parameters and I keep on inputting a lot of information again and again, then somewhere there'll be some information loss because you have to store more information than actually is storable in that small area. So that's what we call fuzzification. So for example, if I ask you guys a memory from when you guys were 5 years old, right? So like we ask you something like, what did you do on this day when you were 5 years old? It's not like your brain never processed that information. It's not like your brain never had that information. It's not like your neurons in your brain never actually stored that information. It was just that because it was from when you were 5 years old and you've actually been inputted with 13 years or maybe 14 years of maybe many more years of data. What's ended up happening is that information that was stored in your brain when you were 5 years old kind of got fuzzified or kind of got overwritten, or kind of there was some loss of information when all of this new information was stored, because the number of neurons in your brain is a constant, right? And it couldn't actually store infinite amount of data. So this leads to hallucination. And hallucination is there across domains. I mean, you can Google this. I'm not going to go through an example right now, but you can Google this and try and figure out what kind of hallucination happens. So reducing hallucination is a large part of LLM applications, enhancing automated decision making, ensuring safer LLM applications, just like what I told you about Claude, right? They're pioneering constitutional AI. So they're trying to ensure that the answers that come out are completely safe, harmless, and are only made for human benefit. So yeah, and then there are some bonus resources over here that you can go through later on. So yeah, I'm not going to go through these bonus resources. You can read through them on your own time. This is encoder decoder architecture, various data modalities, this multimodality of this thing of LLMs, Google Gemini, etc. So let's yeah, and we'll be covering this word vector module very, very soon. So you can check the timelines when we share this with you, and then we'll be covering this very soon. And yeah, I think this covers very thoroughly the basics of LLMs, different companies that are in the space right now, what each of them are doing, different multimodality, hallucination, all of these big fancy words. Attention is all you need, the relevant papers, history of how this thing has come about that you guys can go through. Definitely read through the papers, spend time on it, use different tools to do different things. So yeah, thank you so much. And if Mudit has anything to add, would love to hear it. Otherwise, yeah, thank you so much for listening. And this was the basics of LLMs.
Okay, first of all, thanks, Shaurya, for teaching this particular element. I think it was very beautifully presented. I personally learned a lot of things. a couple of things I would like to add to what Shaurya mentioned is, first off, the generative AI, what is generative AI bit? My bad. For some reason, the module hadn't loaded earlier. It is now visible, so you can go through it. It is a very basic, it contains a basic video from Google Cloud, which tells what exactly generative AI is. So essentially, you know by now what it is, but then it kind of helps you develop a more stronger understanding. One more thing I would like to put across at this moment is, for example, for you to know something uh, um, like the applications of LLM, that particular page, if you look at it. So you should be curious enough from this point itself. For example, I got a couple of queries on DMs around a couple of aspects of it. So around the applications and all. So you should always try to, if you see a particular line mentioned here, just copy paste it on Google and try to search around those lines. For example, if it says, okay, it's used in customer support, where exactly is it used in customer support? Or okay, it's hallucinating. What exactly is it? What exactly is hallucination? What are the types of hallucinations? Is there any kind of research done on it? Is there any kind of publications that are there around reducing it? Because we're talking about very foundational stuff and a lot has happened. So you can, when as you develop those curiosity elements, it will help you learning further. Yeah, that's it. And around multimodality, the reason we included that is because it was, I mean, becoming a lot of buzzword because of at the time we were preparing this curriculum, that's when Google Gemini was released and the video was released. And multimodality, if simply said, is like modes, right? Multiple modes. Modes of communication can be text, it can be video, audio. So multimodality is like having multiple modes in one way. It's kind of an easy way of looking at it. So that's why we included it. For now, if you are feeling like any of the particular module or bonus section is too difficult to understand, you can skip a bonus section, or another good idea will be to simply try to understand from ChatGPT or any of these tools to simplify it for you basis your understanding. Okay, and then you have to verify it because they do hallucinate. Hallucinate is like talking to a professor from USC when it was launched, and he told it in a very decent enough audience size podcast that it's basically a very, what do you call it? Uh, likable bullshit, something like that thing. So it'll very much look like to you that it's very real. So whenever you're trying to learn from it directly, just go and confirm once if it's correct or not. Yeah, that's it. And yeah, I would also thank Shaurya and Aditya and everyone from DevClub for organizing this particular intro session. I think it was superbly helpful. Yeah.
Thank you so much, guys.
There's one question which is sent on a direct message, by the way. So where can we ask doubts outside of the classes? So there's a Discord channel of Pathway. In that, we have created a dedicated channel around called Trust ITD. So let me show that quickly so you know this. Okay. Let me share my entire screen. Sharing entire screen can be risky at times, but I think you can see it. Okay. So when you go here, you should be able to see this particular thing called as Trust ITD B Camp. Okay. So go and join this. Also, there's one more particular channel which may be of relevance to you. I'll put across the links and everything. There's one more channel which is called as introductions. This introduction channels is there for most of the reason I've zoomed in is just to kind of make it easy for you to consume. So for most of the open source communities, we'll notice that there are these introduction channels. Now you can go about, I mean, it's just something that I've recommended in the introductory section as well. You can go about mentioning something like, what, you are happy to be here for the boot camp and everything, but it's important for us to realize a couple of things. One, Pathway is not a boot camps company, so most of the people here are actually not for boot camps. So it may be great if you actually share who you are as an individual, who you are as a data scientist, as an LLM enthusiast. If you've done something, put it across in a way that is that helps you find collaborators in future. That can include people from your college itself, or that can include people from some other parts of the world. Okay, so yeah, that's it from my side. So you got to check this introductions channel and go to this particular channel around Trist Itinerary. Yeah. And you'll see actually very cool folks end up answering questions. For example, Berkey is an LLM researcher. I think he's not online here. But then someone like Mihal, he answers at times. He's somebody who started the first social media in Poland, which is insanely cool. There's also a code jam or something like a finalist for winners. And then there's a lot of people, Jan, Adrian, these people do also answer. So be mindful of, I mean, not in a negative way, but just see this as an opportunity where you can go and also network with good people. So put across the best foot and network with folks out there. Yeah, that's it.